All right. Can you hear me? Should be able to hear me. All right. Give me 1 second. I'm going to try to. Okay. Should be able to see that, hopefully. Let me. Okay. So this is. Man, that is not. Okay. That'll have to work. All right. Okay, so we're going to be going through 9.2. Obviously, if you've already read it, this is just kind of an opportunity to get some feedback on it and ask any questions. So 9.2 is going to be about hurricanes. The last section was about tornadoes and lightning and such things. Very exciting. Hurricanes are intense low pressure systems that develop in the tropics. Remember what a low pressure system is. Low pressure means that the air is moving upward, right? It's rising instead of falling. If it's falling, it creates a high pressure system. Also remember, because of the Coriolis effect, it doesn't just rise. It rises in a circular sort of a cyclone fashion. Looks like a cyclone, right? So this is what creates these hurricanes. These giant whirling storms are accompanied by destructive winds of 119 to 322 kilometers an hour, or 74 to 200 miles an hour. 70-mile-an-hour winds are pretty bad. 200-mile-an-hour winds, you're going to be flying, probably when you don't want to. Torrential rains and high waves and tides. So what these hurricanes do is they'll create storm surges. So the water level will start to rise as the hurricane approaches. A hurricane's massive size and power is unequaled by any other meteorological phenomenon. Right? A large hurricane may be 14 kilometers, 9 miles high, and hundreds of kilometers across. It can release the energy of a 10 megaton bomb every 20 minutes and can move over 1 million tons of surface air into the upper atmosphere each second. Now, that's a lot of stuff, right? It can move a lot. It's got lots of energy, which is why it does so much damage. Although the term hurricane is used in North America and the Caribbean, these storms are known by different names in different parts of the world. In the Western Pacific, these storms are called typhoons, while in the Philippines, they are known as bagyos. In Australia, they are severe tropical cyclones, and in India, they are severe cyclonic storms. So there's different names for them, but at the end of the day, they're pretty much the same thing. Let me pull up. What is this? 254? 54. Should be on 255. Give me 1 second. Oh, did it not? It didn't save. Okay. All right. Okay. So this is 255. Conditions for formation. Hurricanes require two ingredients to form. So this is part of the lesson you're probably going to want to pay attention to. You're going to want to pay attention to all of it, but when it starts to tell you things like this, you might want to write it down. Hurricanes require two ingredients to form: a warm ocean and a region where the Coriolis effect is very pronounced. And think about it. Why would you need a region where the Coriolis effect is very pronounced? Because that cyclone action is what creates these hurricane cyclones, right? You have to have that Coriolis effect. Hurricanes require ocean waters to have temperatures of at least 27 degrees Celsius, 80 degrees Fahrenheit, down to depths of 30 meters, 100 feet. In tropical regions, these conditions are best met from the beginning of summer to near the end of autumn. In the Atlantic, hurricane season is considered to last from June 1st to November 30th. However, hurricanes occasionally occur at other times of the year. So there is a season in which they occur most often, but they can occur pretty much whenever they want. Because hurricanes can only develop where there's a strong Coriolis effect, most hurricanes form between 5 degrees and 20 degrees north or south of the equator. Right? So there are only certain areas where they generally form because they need those certain conditions. They need warm temperatures, warm water, and they need that strong Coriolis effect. Some hurricanes have formed as far as 30 degrees north and south latitude, but this is rare because the water is usually too cold. The latitude numbers, the degrees that it's giving you, if you look at some maps and even a globe, it has lines of latitude and longitude, and it just tells you 30 degrees latitude and longitude or whatever. It will just give you an indication of where it is on the globe. You can identify those. Between 5 degrees north and south latitude, the Coriolis effect is extremely weak, a fact that usually causes storms to have no rotation. So you see the storms that are powerful, but they're not swirling like a cyclone. It's just a regular thunderstorm, right? Although hurricanes rarely form near the equator, Typhoon Vemi set a record in 2001 when it formed at 1.5 degrees north latitude. Birth of a storm. Hurricanes and other rotating tropical low pressure systems are tropical cyclones, right? So any rotating tropical low pressure system is called a tropical cyclone, right? And remember, as I said, the low pressure areas means that the air is being lifted up. And the reason why this is what causes these hurricanes is because the moisture is being lifted up into the air and it feeds these storms. It feeds them fresh, warm, humid air, which is what causes them to grow and become more powerful. A tropical cyclone forms from a tropical disturbance. Such disturbances are often caused by regions of low pressure that travel westward across the ocean with the trade winds. Convection currents develop from these low pressure regions and strengthen as the moisture in the rising warm air condenses into clouds. Right. So the water that's being carried up into the air condenses into clouds. And condensation means that it's changing from gas form to liquid form. But remember, the clouds, the water molecule or the water droplets in the clouds are so small that the air that's rising up into the clouds keeps them from falling, right? And as they condense more and more, remember we said that if the rate of condensation is faster than the rate of evaporation, then the cloud begins to release rain, right? Once the water droplets become too heavy, they can't be held up in the air anymore by that updraft caused by that low pressure region, right? Winds around this low pressure system begin to rotate due to the Coriolis effect. Once the winds begin rotating, the tropical disturbance becomes a tropical cyclone. So imagine this, right? You have this low pressure area, right? It's lifting. Oh, can you hear me? Okay. So if you can't understand, just let me know. You can also rewatch this if it's, I'll have it, the recording up. But just imagine the low pressure area, right? It's the air is being lifted up into the cloud. It's warm. And then also you have this spinning effect from the Coriolis effect. And this causes the entire cloud system to start to spin, which eventually causes the hurricane to form. It would probably help if I closed all these other things that I have going on here. Give me a second. Okay. Well, hopefully it doesn't continue to do that. The warm ocean continues to supply the air with moisture, the fuel of a tropical cyclone, which further strengthens the tropical cyclone and causes the winds to gradually build. Right. So as I said, the storm is fed by this continuing updraft of air, and the storm starts to get stronger. The hurricane as a whole moves in the direction of the dominant winds. North of the equator, this movement is usually toward the west or northwest at speeds of 16 to 32 kilometers an hour, 10 to 20 miles an hour. Although some hurricanes have reached speeds of over 110 kilometers an hour, 69 miles an hour, when the hurricane leaves the tropics, it usually begins to weaken because it is cut off from the warm oceans and moist air that it feeds upon. As it moves onto a continent, it will usually dissipate within a few days into a mass of rain showers. So as the storm begins to weaken, it will start to sort of deteriorate. So let's do. All right, so what we're going to do is cyclone stages. If the rotating winds of a cyclone have a sustained speed less than 39 miles an hour, it is a tropical depression. So that's something to take note of. If the rotating winds of a tropical cyclone have a sustained speed less than 39 miles an hour, it is a tropical depression. About 10% of tropical disturbances make it into this category. Once the tropical depression's winds reach 39 miles an hour, it is upgraded to a tropical storm and given a name. Meteorologists estimate that about 10% of tropical depressions develop into tropical storms. The storm becomes a hurricane if its winds reach 74 miles an hour. 40% to 50% of tropical storms reach hurricane strength. Hurricanes are ranked using the Saffir-Simpson hurricane wind scale, which places hurricanes into 5 different categories depending on their wind speed. Give me 1 second because I'm going to need to, what is this? 256. 1 second. Let me, give me 1 second. Okay. All right. Category 1 storms, the weakest hurricanes have sustained winds of 74 to 95 miles an hour, 119 to 153 kilometers an hour, while Category 5 hurricanes, the strongest tropical cyclones have sustained winds greater. Hold on, let me pull this up. Greater than 157 miles an hour, 252 kilometers an hour. Hurricane Hugo, which ravaged South Carolina in 1989, was a Category 4 storm. An unnamed hurricane in 1935, Hurricane Camille, 1969, and Hurricane Andrew, 1992, are the only recorded hurricanes to have hit the United States mainland as Category 5 between 1851 and 2017. Right? The center of a hurricane is the eye, a region of low pressure a few kilometers wide about which the storm rotates counterclockwise in the northern hemisphere. So if you see the hurricanes, that area in the middle that doesn't have anything going on, it's actually it tricks people, because when the eye goes over, they think it's, they're all good to go, and they don't realize that it's just the calm before the storm. The hurricane's surface winds spiral inward toward the eye due to the low pressure, but are deflected by the Coriolis effect, causing them to rotate around the center of the hurricane and leaving the eye calm. So that because of that spinning motion of the Coriolis effect, it creates that eye in the middle of the storm. So if you think about, if you've ever made one of those science projects, the cyclone inside of a bottle, or if you spin something fast enough, if you look down in the center of it, there's nothing there, right? It's because of the rotation. The force keeps everything on the outside of that cone. And that's the same thing with a hurricane. Although the reason is poorly understood, air in the eye slowly sinks, creating a warm environment in which clouds evaporate and thus leaving the area clear. Hurricane eyes are typically about 30 to 50 kilometers, 19 to 31 miles in diameter, but eyes are as wide as 190 kilometers, 120 miles, have been observed. So, in the midst of this storm is a high pressure area, right? And it's pushing all this air out to the outer bands of the storm, right? So this system feeds itself off of the warm waters and becomes stronger and stronger. This is why when it gets on land, it dissipates, because it doesn't have any more of that warm air to feed it. The calm eye presents a stark contrast to the eye wall. Now, the eye is calm, but the area right outside the eye wall, is extremely dangerous. That's the most dangerous part of the storm. The cylinder of thick whirling clouds and rain that surround the eye, formed by updrafts from the hurricane's warm surface winds. The eye wall may be up to 14 kilometers, 9 miles high. The updrafts exit the eye wall at altitudes of about 13,700 meters, 45,000 feet above the surface, and form outward flowing spirals of wind that flow clockwise in the northern hemisphere, opposite the direction of the rotation of the surface. At lower altitudes around the eye wall are rain bands, long, narrow lines of thunderstorms, long, narrow lines of thunderstorms. Dozens of these rain bands rotate around the eye, slowly spiraling inward as they do so. Winds in the rain bands are strongest near the eye and weakest on the edge of the storm. So you can see this, I don't know if you can see this very well, but the anatomy of a hurricane, you can study that. The rain bands are on the outside. You can see that slowly sinking air in the middle creates that high pressure area. Let me see if I can... see if I can just do this. Yeah, that ain't going to work. Okay, let's do this then. All right, so you should be able to see this now. So this area right here is a high pressure area, right? Because the wind is going downwards, right? These areas out here are the rain bands, right? And there's air that's rising up in these rain bands, bringing fresh moisture and air to these storm clouds. So just imagine that this is a system, a thunderstorm that is eating a lot of food. That's the best way I can explain it. And because of the Coriolis effect, it is causing it to rotate. And so it is a ever-growing, gigantic, spiraling thunderstorm, right? That's probably the best way to explain it. So what I want you to do is go back in these sections and study this. Make sure you understand what it says about the hurricanes, the eye wall, the different categories here. You can see category 1, category 2, category 3, 4, and 5. Look over this stuff, take notes. You will be taking a quiz tomorrow morning. When you log in, you'll see a science quiz available to you. When you're taking the quizzes online, don't worry about your grade. A lot of the times it's going to try to grade you, but it doesn't grade correctly. I'm going to go back through them and grade them. So don't worry about your grade. I'll let you know what your grades are. And that's it. That's the science lesson for today. If you have any questions, you can call me or email me. If you're watching the replay of this, I invite you to attend the live streams. That way you can ask questions. And that being said, my only student who showed up today, Mr. Eric, do you have any questions, sir? Or concerns, issues, or agendas? All right. So I will see you back here in a few minutes for the history stream.